Unit 1 Chemistry, Chapter 1, Part 1. So these videos will go through the key concepts that you need to know for chemistry. This first one, you'll probably find a lot of what we're doing is familiar from what you've done in Year 10. That's okay. Just be reassured, therefore, that you know what you need to start the course. If any of it's unfamiliar, then this should act to help you understand what we're going to expect from you as already knowing your entry knowledge. So, this you should already know. Atomic structure. You should know that we have atoms, which are the smallest indivisible particles, but that they are made up of subatomic particles. You've got a nucleus, which contains positively charged protons and neutral neutrons. And then orbiting that, you've got negatively charged electrons. Okay. The protons and the neutrons have a mass, which is pretty close to each other, which we say is 1 atomic mass unit. 1 atomic mass unit is equal to a 12th of the mass of a carbon-12 atoms. We use a carbon-12 atom because it's got 6 of everything, 6 protons, 6 neutrons, 6 electrons. And then we add them all up, divide by 12. That ensures that we're accounting for the mass of everything equally. Okay? Electrons do have a mass, but it's negligible. It's many, many thousands of times smaller than the mass of a proton or neutron. So, if you want to find the number of protons or neutrons or electrons, you look at the periodic table. On the periodic table, it will have the name, the symbol, and 2 numbers, the atomic number and the atomic mass. Sometimes the atomic number's up the top, sometimes the atomic number's down the bottom, but the atomic number is always the smaller number. I don't mean smaller in terms of text size, I mean smaller numerically. So 6 is smaller than 12. The atomic number tells us the number of protons, and therefore also for a neutral atom, so something which is uncharged, tells us the number of electrons. Because if it's neutral, the number of positive charges balance the number of negative charges, so the number of protons and electrons are equal. The mass number tells us the total mass. That is the number of protons plus the number of neutrons. So if we just want the number of neutrons, of course, we would do the mass number minus the atomic number. Now, you'll have noticed here, this is not an exact round number. You can't have 0.01 of a proton or 0.01 of a neutron. So that's not where the extra mass is coming from. It's also not coming from the electrons, because the electron's mass is way smaller than that. What it's coming from is isotopes. So many elements have 2 different varieties of them. These varieties have got the same number of protons as each other, and therefore if it's a neutral atom, the same number of electrons, but they've got different numbers of neutrons. So up here, for instance, you've got chlorine 35 and chlorine 37. Okay? Chlorine 37 has got 2 more neutrons. That's why it's 37, because that gives it 2 more atomic mass units. Okay? These 2 are isotopes of each other. It's not that this is the normal one and that one's the isotope. We call them both isotopes of each other. This one's more common, this one's more rare, and if we therefore look at the periodic table, we'll see that the average, which is a weighted average for chlorine, gives us 35.5.